In today's class, we are going to discuss the orbital velocity and the expression for the orbital velocity. So let us see what is an orbital velocity. Orbital velocity means if suppose you want any object to revolve around a planet, like you know students, the satellites they are revolving around the planet Earth. And the satellites are giving much information about the earth. What is the size of the earth, what is the shape of the earth, what are the natural resources that are present on the surface of the earth, and they also provide the weather conditions in advance. So in order to make any body to revolve around a planet, or in order to revolve a satellite to revolve around the earth, what we do here is we have to give that object a certain velocity. With that velocity, it is going to revolve around the planet, and that velocity we are calling it as an orbital velocity. So let us see what is the actual definition of the orbital velocity. See, it is there on the board. Now orbital velocity. The minimum velocity required for an object to revolve around a planet in the circular orbit is called orbital velocity. So the minimum velocity, how much a satellite or an object or a body requires so that it is going to revolve around the planet. I can give you here, see, this is an example. Suppose this is a planet like Earth, and a satellite is there, and this satellite is revolving around this planet. Now if suppose I take this is the satellite of mass m, and this satellite is at a height h from the surface of the earth, and we let us consider the radius of the earth as r and the mass m. You can say earth or the planet because earth is also a planet. Now the mass of the planet is m, r is the radius, h is the height above which the planet, that satellite is revolving, the body is revolving around the planet. So if you give some velocity, what you call it as VO, with this velocity it is going to revolve, and that velocity we are calling it as an orbital velocity. I hope it is clear. Now students, you know the electron revolves around the nucleus. The best example what you can give here, the electron revolves around the nucleus. So in this, the force, that is what you call it as the electrostatic force between the electron and the nucleus provides the centripetal force, In the same way, if you see the motion of the satellite around the planet, then the gravitational force between the planet and the satellite or the body provides the centripetal force. The gravitational force here in this situation, the gravitational force is providing the centripetal force, and after this getting the centripetal force, it is easy for the planet, it is easy for the satellite or the body to revolve. Let us see what we are considering here. See, we are considering a planet of mass m, radius r. H is the height from the surface of the planet where the satellite is. Now we are considering the orbital velocity as VO. The same thing I am writing here in sentences. See students, consider an object of mass m, small m, revolving around a planet of mass capital M and radius capital R at a height h. At this height it is revolving. Now since it is revolving, we are saying it is revolving. So what is the reason for this revolution of the body around the planet? The only one reason I can say that the gravitational force is providing the centripetal force. That also we include here. Gravitational force. Very important line. Gravitational force provides the centripetal force. So that I am writing mathematically, that is the centripetal force is provided by the gravitational force. Now students, centripetal force is providing the gravitational force as I said, but what is the formula for the centripetal force and what is the formula for the gravitational force? You should know that. So here the body is revolving here what I can expect here, that is the centrifugal force, and the formula for centrifugal force is mv0 square by r plus h. Why I am considering here it is r plus h? Because the total distance from the center, this is r, try to understand, this is r and this is h, so total distance is what? R plus h. This is very important to note. The total distance from the center we need to take, that is r plus h. So centrifugal force we are getting it as mv0 square by r, but we should know that centrifugal force and centripetal force both are equal in magnitude. So therefore, in place of centripetal force, I will take it as mv0 square by r plus h. And the gravitational force, students, that was given by the Newton, gm m by r plus h whole square. This is the formula given by the Newton, okay, and this is the centripetal force. Both are equal, that's why I am equating. The very important step, m get cancelled. This m and that m also get cancelled. That means the orbital velocity is independent of the mass of the object, because it is, we are getting, this m is getting cancelled here. I hope it is clear. Now this r plus h, 1r plus h get cancelled. Now let us go for the simplification, that is v0 square is gm by r plus h. So this is what v0 is equals to under root of gm by r plus h. Now students, if that this h, if suppose the satellite is very nearer to the surface of the earth, then this h is negligible when compared to the radius of the earth. I repeat once again, when the satellite is very nearer to the surface of the earth, that means height is very less when compared to the radius of the earth or radius of the planet, then we say that the h is negligible and it can be neglected. So therefore h we are neglecting. So here I am writing VO is equals to under root of gm by r. In place of r plus h, I am just writing it as r because I am neglecting h. Now we know the relation between small g and capital G, that is g is equals to gm by r square. Now what is the value for g here? That is gm. In place of gm we can write it as gr square. In place of gm we can write gr square. So therefore just substitute the final step. It is what? Gr square by r. R get cancelled. So VO is equals to under root of gr. So students, this is the expression to calculate the orbital velocity for an object to revolve around a planet where the gravity is g and the radius as r. Now the very important thing here, you are not getting any m term here. Small m we are not getting. The reason here is m is getting cancelled. That means if you want to revolve any object of mass 1 kg, the velocity must be this much. Any mass if you are considering of 10,000 kg, how much it should be the orbital velocity? The same orbital velocity, because in this formula we are not getting any small m later. So therefore it is independent of the mass of the object, or I can say it is independent of the mass of the satellite. I hope you have understood the complete concept of orbital velocity along with its derivation. Hope you have understood this. Thank you.